Good morning, all of you. I am Mani Mahesh. Today I am going to discuss about geophysical method. Although the boring we know that and the test pits provide definite result, but they are time consuming and expensive. Whatever study we had done in the boring, all the study are time consuming. Subsurface conditions are known only at the bore or test pit location. We can only know about little bit about where we conduct a test. Through the geophysical method, we can get the data in a very short time, and it is cover more area as compared to boring test. The result of geophysical method testing, however, less definite and requires subjective interpretation. Therefore, both methods are important. In case of geophysical testing in measure in scope, few boring or sampling will be required for accurate determination of soil property. Both the method, the boring test and the geophysical method, both are important in their place. But the geophysical method give you a result in a very short time and need a very skilled person who can interpret the data. Now, basically the geophysical methods are two types. First one is seismic or refraction method. Second one is resistivity method. Geophysical methods indicate general boundaries of drastically dissimilar layer. Most commonly used geophysical method, which I have already discussed, one is refraction method, second one is resistivity method. Seismic or refraction method, a shock wave propagate in an elastic medium with a velocity v is equal to m upon rho. M here is modulus, rho is mass density. Okay, so then here is velocity of wave in soil 150 to 3000 meter per second. In rocks it is 1500 to 6000 meter per second. Response of a shock wave emanating from a source and picked up by geophone are known distance. So, which we will discuss this later. Here we will only know when uh, the speed. First method is the instrument setup of seismic refraction method is like this. Is the energy source. This is a detectors. When and these are the soil layer, first layer, second layer, and third layer. And according to we distribute, first one layer is unsaturated layer, second is water saturated layer, third one is the bedrock layer. According to this layer, we can convert these layer in a front view like this. Geophones layer 1, layer 2, layer 3, the distance is h1, h2, h3, and through this layer, first one we stuck a impact load on a point P. Some of the energy is directly goes to the geophone's x naught, and some will be passed through the soil layer at a speed of v1. When the speed is v1, then some of the energy will when passes through the layer 1 to layer 2, some of the energy is converted, v1 velocity is converted to v2 speed, and again it passes through the layer 1 and gain v1 speed and goes to the geophones 1. Some of the energy through layer second will pass and goes to layer 3, and again that will be go to layer 2 at a speed of v2 and at a speed of v1, and again goes to the geophone of x2. The A, B, and C, these are the three geophones which directly get the shock waves at a different time interval. The layer thickness is h1, h2, and h3. Suppose then the value of h1 will be equal to x1 upon 2 root v2 minus v1 upon v2 plus v1. Means the speed means the displacement from the P point to x1 point, the P point to x2 point, and the time. When you stuck an impact point on P, the wave consumed time to get information by a geophone x1, the time required. we will get the value of v1, means velocity is equal to displacement upon time. So we get v1 and v2. According to that, we will find h1 and h2. The formula is given here. This is about the method. The depth of a rock underlying the soil or depth of the water table can be obtained. Shock wave emanating from the dynamic charge forming a source as traveled through the soil and picked up the geophone 1 to 3, which I already discussed. One shock wave travel directly through the topsoil layer in velocity v1, another get reflected with a greater velocity v2. After that, distance from the source x and the time, wave time, we can draw a graph. The first x0 to x1, the time is t1. Through x1 to x2, the speed is v2 and time is t2. And then we know that, and the layer 1 we will get the time as very short time. We will get information at the v2, we will get a letter, and at the v3 we require more time. In that case, we will provide a slope v1 10 alpha, v2 10 alpha 2, v3 10 alpha 3. Okay, so we can easily find the time and this distance. Okay, and through this graph we can also find the velocity. We know what is the distance between origin to x1, origin to x2, origin to x3, and the time, the information get by the geophones through the velocity v1, through the velocity v2, and you can easily find the v3 according to the angle, whatever angle you get from the here. So through here you can also find the t1, t2 and velocity, and we can find after that h1 and h2. The break of curves represent point of simultaneous arrival and primary referred wave, and its distance is known as critical distance. The wave velocity through the rock layer is many times greater than the through soil layer, which we already discussed, around 150 to 15 and 153,000 and 1500 to 6000. So the time of arrival of longer route is shorter than that by the shorter route through the topsoil. The velocity v1 is equal to d2 minus d1 upon t2 minus t1. According to it, we will find h1. Seismic reflection method is fact. This method is reliable in stabilizing profile of different strata. The type of material in various layers can be determined by comparing the velocity obtained with the standard velocity given in table. So these are the velocities. Suppose you have a granite, the velocity is 4000 to 6000. If there is sandstone, the velocity is 500 to 3000. The velocity different, and if you get velocity range like this, you can say that this type of soil will be there. Okay, now what are the limitations of the seismic method? The method cannot be used if hard layer with a greater seismic velocity overlie a soft layer with a smaller seismic velocity. Means if you get here a velocity is greater, a method can use hard layer with a greater seismic velocity overlies. If a velocity overlies like this, if is a hard and if it is a soft, what happen when the vibration will come from this direction, then this will directly travel to geophone. The energy will be observed by this rock is very less. Okay, so the energy will go very less. Now next is resistivity method. The electrical resistivity method is based on the measurement and recording change in mean resistivity of various soil. I will show you figure here. Electrical conductivity of soil layer depends upon the concentration of the iron salt in the soil pores. Each soil has a resistivity depending upon the water content, compaction and composition. The figure is like this. What we will do, we will provide the electricity the electrode at a distance d and on the ground surface. First we will provide the potential, we see the potential difference. Again we just increase the difference, we increase the distance d, again find out and then find the distance d. If there is a hard layer, okay, if there is a hard layer, the potential difference will be very high. If there is a soft layer, then the potential difference will be very low. According to that, we will find out the velocity of the resistivity, that will be equal to 2 pi d E upon I, and here where rho is equal to resistivity, d is the distance, E is equal to potential drop between outer electrodes, I is equal to current flowing between outer electrode, R is equal to resistance. If the value of rho resistivity is greater, then that means the soil is hard. If the value of rho is less, that means soil is soft. This is the procedure. It consists in the 4 electrode, which I already discussed. We just increase the distance of the electrode and see the potential change in the electrode. Mark change in potential indicate the presence of stratum of different resistivity. Okay, so these are the two tests which we are generally used in geophysical method. Uh, first one is seismic method, and second one is resistivity method. In the seismic method, we will just create an impact load on the soil surface, and whatever the geophones getting the information about the wave which is propagated through one layer to the second layer. According to that, we will find h1 and h2, and here and then first velocity and then h1 and h2. In the method of resistivity method, we will just place 4 electrode on the ground and just increase the distance between all the electrode and see the potential difference when we are going to increase. If the potential difference is high, then we see the soil will be hard. If it is low, then it is, if the potential means if the value of potential of 1 and potential of the 2, the value is supposed 20 and one value is 3, then the 3 value is high, here 20 is less, means the potential difference is very minute, means the soil is there will be rock. If the potential difference is high, means the value is 20, this means soil is soft. This is for today. Okay, have a nice day.